Yes, sir.
Yeah, okay, great. You can off your video. We don't need the video actually. And please keep yourself on a mute. Yeah, hi, good evening. We are going to start now. I hope I'm on the app now you can hear me.
Yes, sir.
Yes, sir.
You can off your video. Video is not needed actually from your side. Okay, people are still joining, so I need to admit them. Okay, fine, guys. So let's start. So I welcome you all for this demo session of statistic. Okay. Okay. So today we'll be discussing this two topics: parametric, non-parametric, and descriptive, inferential. Okay. Now, basically, statistic, like we have a problem and we need to look for the solution, and that the journey of that problem to solution. 1 minute. People are keep joining now. I need to admit them. Yeah. Okay. So, like we do have the problems and we need to look for the solution, and this problem to solution journey basically involved the research. And when we talk about the research, there are basically two types of a research. One is a qualitative research and one is a quantitative research. You can join through Google Meet also. The link is shared in the group. Okay, and I shared the link here also. Now, when we talk about the quality research, okay, it's like a text, words, and case study basically, which is widely used in a psychology. But at the same time, we do have the quantitative research also, that is the numbers and the data. And when the numbers and data is there, we need to use the statistics. A very good example of this is like you can say the a movie review. Okay, the movie review. Now whenever we go and see that review, okay, so we can get the what you can say that the point system, the star system, 4-star rating and 4.5-star rating. So that star rating is nothing but the quantitative, that quantitative data. And when someone write a few paragraphs of 3 hours movie, that is a case study, that is a qualitative. Okay. Now, so we do have the numbers and data, and if we want to take the information out of that data, then we need to use the statistical tool. Okay. And still people are joining, just a moment. Okay, now listen carefully. So statistic is a decision science. Okay, based on the statistic we take the decision. Now, in statistic, we do only three things. Please listen carefully: the relationship, the differences, and prediction. Apart from these three things, we are not doing anything else in the statistic. Okay, either we need to find out the relationship, or we need to find out the differences or the prediction. Now, whatever you will do in your MAPC psychology, whatever you will do as a numerical, as a statistic, you will be trying to find either the relationship or differences or prediction. We will be taking the decisions for this three only. Okay. Now, let's see one by one. People are still joining, guys. Please keep yourself on a mute. Yeah, thank you. Now, see, the number one is a relationship. Okay, in statistic, we need to find out the relationship. Say, for example, the two variables are given to you, X and Y. And you need to find out whether these variables are related or not related. This is what the relationship. Now, two possibilities here, X and Y. Either they are related or they are not related. These are the two possibilities. When we need to find out the relationship between the two variables, two possibilities, either X and Y are related or X and Y are not related with each other. Now, if they are not related with each other, there is no issue. But when relationship established between X and Y, then we have the two possibilities. Either they are positively related or they are negatively related. These are the two possibilities. Either there is a positive relationship or there is a negative relationship. Now, what is a positive relationship and negative relationship? As we say, there are two variables, X and Y. So, in case of a positive relationship, when as X goes up, when X goes up, Y will also go up. And when X will go down, Y will also go down. It means both the variable will move in the same direction. Then we'll call it as the variables are positively correlated with each other. Like if you study more, you will get good marks. If a person if the person smoke less, if you study less, you will get the poor marks. Okay, so this is what the example of the positive relationship. Okay, what about negative relationship? Say, for example, again you have the two variables X and Y. So one variable is going up, another variable will go down, or if one variable is going down, another variable is going up. It means that the variables move in a opposite direction. Then we called it as a negative relationship. Then it is known as a negative relationship. So I repeat again, relationship, you have the two variables X and Y. Two possibilities, either they are related or they are not related. If they are related, then there is a possibility of positive relationship or negative relationship. Positive relationship is when variables are moving in the same direction. Negative relationship means when variables are moving in a opposite direction. Okay, so this is a simple funda of the relationship. And what statistical tools we are using? So we are using the product movement correlation, Kendall's rank, Spearman correlation, and the chi-square. So these are the statistical tool which we will be using in relationship. The second one is a differences. So again, we have the X and Y, and we need to find out if there is any difference or not. Now, two possibilities again here in between X and Y as far as difference is concerned. Either they are same or they are different. They are same means there is no difference. X is equal to Y. It means that both variables are same. Now, when we'll say there is a difference, so there are two are two possibilities. Either x is better than y or y is better than x. So there are two possibilities. So in this case, we'll select x. In this case, we'll select y. Okay, because those are better. So in statistic, we need to take the decision which option is a better. That is a differences. So when two variables are given, two possibilities, either they are same, it means there is no difference, or they are different. When they are different, it means either x is better or y is better. And what tools we are using? T-test, ANOVA, and U-test. Now listen carefully. The difference between the T-test and a U-test. Okay. T-test, student T-test we also call. We have the two variables. If we have the two variables, we will use the T-test. And if we have more than like 3 or more than 3, say for example, you have the x, y, and z, then we use the ANOVA. That's a basic difference in a T-test and an ANOVA. T-test we use if we need to find out the difference between two variables. And if there are three variables or more, then we'll use the ANOVA. That's a basic difference in a T-test and ANOVA. Okay. And number 3 is a prediction. If x and y are related, then I can predict the y based on the x. This is a prediction. Okay. So prediction means seeing the future. Okay. We are trying to predict the future. What will happen in the future. Okay. With the variable. So when x and y are related, so if we know the x, then we can easily predict the y. This is a prediction. Okay. And the tool what we are using here is a regression. So I repeat again, in statistic, you are doing only these three things. Either you are going to find out the relationship or difference or prediction. Whatever numericals you will do, you will be doing either this, any one out of this three: relationship, difference, or prediction. And these are nothing but the decision. Okay, so you will be taking the decision for the relationship, or you will be taking the decisions like which option is a better, which variable is a better, or you are trying to predict. In day-to-day life, whatever decision we are taking, those decisions are based on these three things only. Okay, and that is the reason why statistic is known as a decision science. Now see, statistic broadly classified into two types: descriptive statistic and inferential statistic. So we'll see one by one. First, we'll see the descriptive statistic. Descriptive statistic, what we have, the organizing and summarizing. Okay, now let's see. In statistic, you will always get the numbers like this. These are the raw data. This is the raw data, and the numbers will be thrown to you in this manner only. There could be 10 numbers or 10 million numbers. It will be always the random data, okay, given to you. Now, the moment you get the raw data, the first thing what you need to do is organize it. And the next is summarize it. What you need to do? First, you need to organize, then you need to summarize. So how we do the organizing? That is a table and a graph. And how we summarize? Central tendency and a variation. These two things we normally use. Okay. Now let's see. Now the problem with this raw data is to answer the very simple question from this data, it becomes like a very time consuming process. Like if I ask you, like which is the smallest number and which is the highest number from this data. Okay, so can you give me the answer? Can you tell me which is the smallest number and which is the highest number?
So the highest
53.
one is 121.
121.
125.
No, sir, 125.
125 is the highest and lowest is 53.
Okay, lowest is 53.
53.
So now answering a simple question, which is a time consuming process. But now you see the data is grouped. Now it becomes easy to read the data. It becomes easy to conclude the data. It becomes easy to take the information from the data, because we organize the data in a table form. The next thing is the graphical representation. Now here if I ask you which data set is having the highest frequency, again you need to go through the numbers, all the numbers. But answering that question again become easy the moment you see this graph. Okay, here you can see the 33. This is the highest. So various graphs are there. This is another graphical presentation. This is the line chart. Okay. So this is what, the moment we get the raw data, first we need to organize and then we need to summarize. So organize we did with the help of table and a graph. Now summary. Now I'm having 100 numbers I'm having. Now as a data analyst, as a statistician, if I got the 100 numbers, my job is to summarize those 100 numbers. Okay, so how we do the summarizing? Central tendency and a variation. These two things. In statistic, we are doing these two things mainly. Find out the central tendency and find out the variations. And based on these two things,
So,
we make a decision.
and the standard deviation.
Please keep yourself on a mute. Okay, so let's see one by one. I will be explaining how we will use this, in like to take the decision. Now central tendency, we have basically three: the mean, median, mode. These three central tendency we use. The moment you get the data in your hand, the raw data, the first thing what we do is find out the center value of the data. Find the center value of the data. What is the center point of the data? We need to find out that. And what are the various central tendencies? The mean, median, mode. What is the mean? Mean is an average. So how we find the average? Add all the numbers and divide by the frequency. Say for example, if you have the number 1, 2, 3, 4 and let's say 5. So how we do that? 1 plus 2 plus 3 plus 4 plus 5. And then 1, 2, 3, 4, 5 divided by 5. Okay. And when you will do this, solve this equation, you will get 3. So that 3 becomes the average for this data. What is the middle value? The median is a middle value. When you arrange the data in ascending order or descending order, the number which is coming in the center is your median. Like for this, say for in this example, 3 is a median value. 1, 2 on the left, 4, 5 on the right. So 3 is in the center. What is the mode? The mode is the one which you see the most, the number with the highest frequency. So we'll see this graphically and then we'll see the example also. So see the mean. Mean is a balancing point, center point. Okay. Now what is the median? Median is, you can see 1, 2, 3, 4, 5 numbers this side, 1, 2, 3, 4, 5 numbers this side, and this is the center number. What is a mode? You can see this is a unique one number, only one number you have. This is you are having twice, and this number you have thrice. So this is the highest frequency. The one number coming thrice. This other one number is coming once. This number is coming twice. These two numbers are coming once. But the number which is repeating regularly most of the time, that becomes your mode. See the example which I already gave you. So I'm having this data set 20, 18, 15, 15, 14, 12, 11, 9, 7, 6, 4, 1. This is the raw data you got. You need to find out the mean. So what we did, we just added all the numbers and then we divided by the total number, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And once you do this calculation, you will get the average of the data. And this average is nothing but the mean. And that mean is a central value. See the median, as I told you, arrange the numbers in ascending order or descending order. So this is like 1, 2, 3, 4, 5, 6, 7 numbers are there. We arrange the number in ascending order, means this is a small number and this is a biggest number. And the center number, whichever is coming, is the median. Now this is an odd data set. Odd data set means you have the 1, 2, 3, 4, 5, 6, 7. Odd numbers you are having. Here if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 numbers you have. So when you have the even data, so it means you have the two data in a center. If you see this is 1, 2, 3, 4, 5 this side. 1, 2, 3, 4, 5 this side. So whenever you have the two data, like in even data set, you will have the two numbers in a center. Then what we do, we take the average of that, and that becomes your median. So here for this data set, 12.5 is the median. Why? Because we have the two numbers in the center. In this case, we have only one number in the center. So it becomes very easy. Only one number. But when you have the two numbers in the center, that is possible in even data set, then we need to take the average of that two number. And then that average will become your median. This is a mode. The number which you see the most is a mode. Okay. So here if you can see the 74 and the 74 is coming twice. Okay. Rest 1, 1, 1, 1, 1, 1. All numbers are unique. Only 74 is coming twice. So for this data set, the mode is 74. Okay. So this is what the mean, median, mode. Is that clear to you? Any doubt you have till now?
No, sir.
Okay, great. Still people are joining. Okay. Now see the example. Like we have the the IQ for two classes of 13 students each. So class A, IQ of 13 student is given to you. Class B, IQ of 13 student is given to you. And now which group is a smarter? So if we need to find out the which group is a smarter, we need to find out the mean of this and mean of this. So we got the mean. So this is the average of class A and this is the average of class B. And they are roughly same. Okay. So with the help of a descriptive statistic, it is easy to answer the question. Okay, so in case of organizing the data, like the moment we get the raw data, the first thing what we need to do is organize the data. Second thing what we need to do is summarize. In summary, we saw the central tendency, that we need to find out the one value, the center of the data. Okay, center of the data we need to find out, and now we need to find out the variation. Here we saw the center of the data, mean, median, mode. Three central tendency we need to, like, is a in a central tendency we have the three: mean, median, mode, and depending on the situation we need to find out either mean or median. Okay, normally in psychology we don't use the mode frequently. Variation. Now listen carefully, the most important concept in statistics. A measure of central tendency, what we saw, the central tendency, it provides the information about the middleness. It provides the information about the center of the data. Okay, so this is a data, and where is the center point of the data? It talks about that. Okay, but it is not talking about the width or the spread of the distribution. It is not talking about how the data is distributed, the width. Now say for example, see here, this data is distributed this much and this data is distributed this much. So we need to find out the width of the distribution, how much that data is distributed, how much that data is spread around the center. So for that we need to find out the variability or dispersion or the variation. So we need to find out the dispersion or variation or variability of the data. That is the variation. See here, this is the variation. So what is summarizing? Basically, we need to find out the center, and then we need to find out how much the data is, distributed, the width of the data. Okay, now let's see, for example, this is the center. Okay, 0, and this is the 1 and 1. Now in another case, this is a 0 and this could be like a 2. This could be like that. So here the spread is more and here the spread is less. How much data is scattered? How much data is away from the center? Okay, that we need to find out. That is a variation. So in statistic, basically I told you we do only two things: find out the center and find out how much the data is away from the center. Only two things you need to do in a statistic. Apart from that, you are not doing anything else. T-test, ANOVA, Spearman, correlation, whatever, chi-square, whatever you are doing in statistic, whichever numerical you are doing in a statistic, you are doing only two things: find the central tendency, find the variation. That's it. In entire statistic, you are not doing anything else apart from central tendency and variation. Central tendency, variation. That's it. Now let's see. Just a moment. Some student is asking some question, I believe. Yes, Sangik. Any doubt you have?
So what is the standard deviation?
We have not reached to that point yet. Okay, we are going step by step.
Okay, sir. Okay, only these two. Okay, sir.
Yeah. Now guys, listen carefully now. Okay, be with me. If you have any doubt, please ask immediately. Now, a classic example given in a statistic, the Sehwag and a Dravid. Both were Indian cricket team batsmen. Runs in a first inning, Sehwag 100 runs, second inning 10 runs. And if you do the total 110, average is 55. Rahul Dravid runs in a first inning is a 50, runs in a second inning 60. Again, total is 110 and average is 55. Okay, very simple example. Now let's see. Now Sehwag will say the variable x. Someone is trying to join. We'll call it as a x. So this is your x1, value of x1 and x2. This sign stand for summation, means total. So total is 100 plus 10 is equal to 110. And this is a x bar. This is a x. And on the head of that, there is a horizontal line. And we called it as a x bar. X bar is nothing but, this is the average. Okay, mean. Average, we call it as a x bar. So 110 divided by 2, because we have the two numbers here, and that is a your x bar. Your average is 55. Okay, now see this one. This is the x minus x bar, and this is x minus x bar. Okay, now what is x minus x bar? X minus x bar means mean difference. So what is the mean difference? That how much the x is away from mean. So what is the mean? Mean is 55. So this is a 45. Okay, so sorry. This 100 is the x minus 55. That becomes 45. And 10 minus 55, that is become minus 45. So see here. This is my 55 is an average. That is a mean. And nothing but the x bar. And my one number is 110 and my another number is a 10. So here x minus x bar. So this is my x1. This is my x2. So x minus x bar means how much this is, like, how much the distance of this. So this is x minus x bar. That is a 110 minus 55. Sorry. Yeah. And it is actually 45. So this distance is a 45. And similarly for here, so here it will come minus 45. So this is what my x minus x bar, 45 and minus 45. And when I will do the total, so 45 minus 45, obviously 0. So this 45 and minus 45 is nothing but the mean difference. This is the mean difference. What is the mean difference? Mean difference means how much the point is away from the center. 55 is the center point. And you need to find out how much your data is away from the center. That's what a mean difference. Okay. And now this one is like the moment I get the 0 here after total. Now in statistic or in the mathematics, you can't do addition, subtraction, division, multiplication with the help of 0. No statistical function you can perform. So we need to get rid out of this 0. And now here you understand minus 45 and plus 45. The total is 0. But if you see from here to here, it is a 90. The distance. If you consider just the numbers, so 45 you have here and 45 you have here. And when you will add that, you will get the 90. Okay. Now that, in order to get that number, we need to take the absolute value. Okay. We need to take the absolute value. Absolute value means what? If minus 45 is there, we'll take only the number into the consideration and we'll ignore the negative sign. Okay, that's an absolute value. And it is considered as a distance from the zero. Imagine this is like a 55, 110, and this is a 10. So this is minus 45, this is plus 45. So what we are doing, we are taking the distance. How much this 10 is away from 55 is a 45 points. How much 110 is away? 45 points. So this 45 plus 45, this 45 plus 45, and that is what, a 90. So this is my absolute value. Absolute value means I'm considering only number. I'm ignoring the positive and negative sign. Okay, this is a function in the mathematics. So when we do this function, the negative becomes positive. And why we do that basically? Why we do that? Because this total is a 0. We can't do anything with the 0. So we ignore the negative sign. We add the numbers and we get this 90. Now we can perform some mathematical function on this 90. Okay, so this is what the mean difference, this 90. Okay. See this, in case of a Dravid, you have the 50 and 60 runs for the Dravid. We'll say the Y variable. This is the Y1, this is Y2, this is summation of Y110, and average is 55. Again here, when you will take the mean difference, you will get minus 5 and plus 5. Again here it is a 0. So then we'll take this. This is known as a modal value or absolute value. So minus 5 will become 5 and this 5 will become 5 and this total will become 10. Right? So this is what the mean difference. We are trying to find out the mean difference, and that mean difference is nothing but how much you are away from the mean. How much you are away from the center. In this case, this is 55, 110, and this is 10. So this distance is minus 45 and plus 45. In case of a Dravid, it is 55, 60, and 55. So this distance is minus 5 and plus 5. And now what we are doing? We are taking the average of mean differences. So this is the mean difference 45. This is summation. That is the total is a 95. And when you will take the average of this will become mean deviation. Here is a 5, 5, 10 divided by 2. So mean deviation. So what is a mean deviation? So mean deviation is nothing but the average of mean differences. This is the average of mean difference. Because you have the two numbers, the 100 and 10. The mean difference is 45 and minus 45. So you have the two numbers, but we need, remember we are doing the summarization. So in summarization, we need only two numbers. So the moment we have the two numbers, we'll convert that into the one number. So 45 plus 45 divided by 2, that is a 90 divided by 2. And this is a 45. So that becomes your mean deviation. That is the average of mean difference. So how much deviation for Sehwag? Can you tell me? How much deviation for Sehwag?
45.
45. See here. This is 55, 100, and 10. This is 55, 60, and 50. So what is the deviation? 45. And what is the deviation in case of a Dravid? How much data is deviating?
5.
5. So where the deviation is more?
Sehwag.
Sehwag. Now, if deviation is more means variation is also more. So which one is more reliable?
Sehwag.
Dravid, sir, Dravid. It has less
Dravid.
variation
Dravid.
because.
Because Dravid has a less variation.
Oh,
Remember
okay.
the concept. Variation should be less. If variation is less, it means that consistency is more. Less variation means more consistency. More consistency means more dependability. And more dependability means more trust. Recall my words. Statistic is a decision science. So when you need to take a decision, which decision is good? The decision with the more variation or the decision with the less variation?
Less variation.
Less variation.
Less variation, because it is more stable. Less variation means more consistency, more dependability, and more reliability. And there is a good possibility that your decision will be right because the variation is less. So, as I told you, in statistic, the central tendency and variation, and wherever there is a less variation, we'll accept. And if variation is more, we will reject. That's a simple funda we use in a statistic. If variation is more, reject. If variation is more, then consistency is less, dependency is less, stability is less. And there will be more chances that your decision may go wrong. So in statistic, if variation is less, we'll accept. If variation is more, we'll reject. That's the simple funda we use in a statistic. Accepting or rejecting. Again, this mean difference and the mean deviation, this is an important concept. So I will take one more example for you. And I'll try to explain you that. We took the simple example of Dravid and Sehwag. Now let's understand the mean deviation, mean difference with the help of this example. Now here I am having the 8 values. 3, 6, 6, 7, 8, 11, 15 and 16. Please listen carefully. Okay. Now, on this graph, first we will place the numbers. Like on x-axis, we have these numbers. So this is number 3. So in between 2 and 4, we need to place the 3. And how many numbers we have? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So number 2 is a 6. So where that number will come? Here. See, number 2 is a 6. Number 3 is another 6. So it will come here. Then we have the 7. So 7 will be here. Then we have the 8. Then we have the 11. Then we have the 15. And then we have the 16. So just see. All the numbers are placed like this. Okay. Now, the moment we get the number, what we need to do? We need to find out the average. So this is the average. Average is a 9. So that 9 is nothing but the x bar is equal to 9. And what we'll do? We draw this line. And that becomes your mean. So this is the average of the data. x bar is equal to 9 is the average of the given data set. Now, this is the x value and the value of this x is the 3. Now we need to find out how much this 3 is away from the mean. Now what is the mean? Mean is a 9. And what is our formula for mean difference? That is a x minus x bar. That is a 3 minus 9, and that is minus 6. Sorry. So that x for which the value is a 3, just a minute. What is the mean difference? So for mean difference, we need to subtract that number from the mean, that is a 9. So 3 minus 9 is a minus 6. It means this x is minus 6 point away from the center. In the similar way, this is a 8, sorry, this is a 6, 6, 7, 8, 11, 15, 16. If you see this is a 6, so this is minus 3 point away, this is minus 3 point away, this is minus 2, this is minus 1, this 11 is 2 point away, this 15 is a 6 point away, and this 16 is a 7 point away from the center. So all these are the what? Mean differences. See here, x minus x bar. So we have the 8 numbers, and now we know each and every individual number is how much away from the center, and that is nothing but the mean difference. How much the numbers are away from the center, away from the mean, away from the average. So minus 6, minus 3, minus 3, minus 2, 1, 2, 6, 7. Okay. So now we know how much the numbers are away from the center, and if you total all this, it will be 0. Remember my word, total of mean difference is always 0, no matter you have the 2 numbers or 2 million numbers. No matter how many numbers you are having, your total of mean difference is always 0. Why? Simple logic, mean is a center point. Half number this side, half number this side. It's in the center. So obviously 50% this side on the right side, 50% on the left side. So when you will total this, it will always become a 0. That will always become a 0. So that's the reason why we need to take the mode value, that is an absolute number. It means 6, 3, 3, 2, 1, 2, 6, 7. See, we need to take the absolute number, and then 6 plus 3 plus 3 plus all that thing divided by 8. So then we'll get a 3.75, and that 3.75 is a mean deviation. Mean deviation means average of mean difference. So here we'll make a statement that on an average, please listen carefully. On an average, the data is 3.75 points away from the center. I repeat, your data, the center point is a 9, and on an average 3.75 points away from the center, on an average, because every individual number is away certain point. Now here 8 numbers are there, but imagine if you have the 100 numbers, then you will have the 100 mean differences. If you have the 1 lakh numbers, then you will have the 1 lakh mean differences. But we are talking about variation. We are talking about, the summarizing. So if you are giving me the 100 numbers and I'm giving you back the 100 numbers, then that is not a summary. So I'm having the 8 mean differences and average of that is a 3.75. So when you will give me the 100 numbers, I'll give the 1 average. When you will give me the 1 lakh numbers, I'll give you the still 1 average. On an average, your data is 3.75 away from the center. And that is what the variation. How much you are away from the center. And that's what we are trying to find it out here. Just a moment. Let's see here. Summarizing central tendency and variation. We need to give one number for central tendency and one number for variation. Only one number. So when I am having the numbers of mean differences, I will take the average of that, and that average will become my variation. Okay? Yes. Any question? Yes, Nidhi.
Can variation be a negative number?
Possible.
Okay.
Okay. Now let's see. Now see that we saw the various types of a mean deviation. Now we'll see the various type of variations. Okay. Yes. Any more questions you have? Yes, Anu? Please ask. Can you hear me? Yes, Madhu. Please ask.
I don't think the variation can be negative, no, because we are just taking the average of those numbers which are like we are anyway excluding that positive, the negative to positive. How can the variation be negative?
Yes, at this point of time, your question is what you are saying is right. But when you will get when you will solve the numerical for t-test, you will
Am
get
I
that
audible now?
variation. Yeah, 1 minute, Anu.
Okay.
I'm answering the question. Madhu, when you will solve the t-test numerical, then yes, in certain numericals you can get the variation in negative, because see, we are trying to find out how much you are away from the center. So you can be negatively away from the center and you can be positively away from the center. Both scenarios are possible, right?
Right.
Yeah.
Okay, got that. Thank you.
So when you will solve the numerical, I know that it's too early to comment on that. Like I said, yes, negative is also possible.
No, but
it is
I understood.
possible.
Understood.
Yes.
Yeah.
That is in t-test you can get the negative answer also. That's why I said yes. Okay. Yes, Anu.
So I was asking the same. If we are taking absolute terms, then how we are going to get negative result?
No. See, I explain only one concept to you, and that concept is a mean deviation. We need to see the variance also and standard deviation also.
Okay, sir. Thank you.
Okay, I just explain you the one concept. So see what we saw. Like initially we got the mean differences, then we took the average, and that becomes a mean deviation. That is a one way to find out the variation. Okay. Another is the mean differences you have, Now here you took the absolute value. Remember, the moment you get the negative, here with the help of absolute value, you convert that into the positive. Another way to convert the negative into the positive is a squaring. Negative into negative is always positive. So mean difference is square it, then you take the average, it becomes a variance. I repeat, mean difference is like 8 numbers you had, then you take the square of those 8 numbers, then you average, and that average is a variance. Now here we square means we double all the numbers. 2 become 4, 3 become 9, 10 become 100. We explode the numbers. So we need to neutralize. So we took the square root of this variance, and that becomes a standard deviation. That becomes the standard deviation. So I repeat once again, listen carefully. The mean difference you need to find out of all numbers, and when you will take the average, that becomes a mean deviation. Mean difference is take the square and then take the average, so that becomes a variance. As you squared and explode all the numbers, so we need to neutralize with the help of a square root, and when you will take the square root of this variance, that becomes a deviation, which is a standardized. Okay, now this example we saw already, and here we find the mean deviation. Okay, so what we did here to find out the mean deviation, we took this mean difference, we added here, divided by 8, we took the average, and that becomes a mean deviation. Now see the another, this is the mean difference, and here you took the square of that. See, all the numbers are squared. So minus 6 becomes 36, minus 3 becomes 9, minus 3 become 9, 2 become 4. Like that, we got all the numbers, and the total of this is a 148. And when we'll take the average, so first we did a mean difference, then we did a square, and then we took the average. So 18.5 is the variance, and when you will took the square root of this in the next example, that becomes a deviation, which is a standardized. That is a standard deviation. Now see here the explanation. While variance gives the rough idea of a spread, standard deviation is a more concrete, and it gives the exact distance from the mean. So on an average, the deviation of the data set is 4.3. That's what a standard deviation. Remember, more variation, okay, is a less reliable. Always remember that. So the variation should be in a range. Now, I'll give you one example. I hope that will make you understand very fast. Now, the maid comes to our home every day. Now, let's say, for example, maid is coming at 9 o'clock. Her time is fixed. Whenever she comes to our house, her time is fixed. That she will come at 6 o'clock, 7 o'clock, 9 o'clock, 10 o'clock, 12 o'clock. For everyone, this could be different. Let's say on an average, she comes at a 9 o'clock. But is that a case? Every day she will come exactly at a 9 o'clock? Is that possible? She is coming every day exactly at a 9 o'clock. She will come.
No, sir.
Not possible, sir.
No. So let's say her window is 8:30 to. In between, she can come. So as long as she is coming at, say, for example, 8:40, 9:20, 9:15, 8:50, that's all acceptable. What is the range? 8:30 to 9:30. Is that possible to give the range of 2 hours? Is that possible?
No, sir.
No, because that variation is too much. Imagine morning 9 to 11, she can come at any time. That's not possible. Okay, because we won't be able to take our decisions. We know when maid will come, before that we need to finish some work, and once she leave, we need to do some other work. Now, if you don't know when she will come, you will not be able to take your decisions. Okay, so this range is a high, variation is more, so dependability is less. Okay, and here the variation is less. This is not acceptable. So this is reject. Listen carefully. If on an average your maid is coming at 10 o'clock, not acceptable, because the limit is a 9:30. If your maid comes at a 7 o'clock on an average for a month, that is also not acceptable. Now, one day she will tell you, "Ki, I need to go to the school of my son. Can I come at 7:30? For a day. Can I come a bit early because I need to go to school?" What you will say? Yes or no? Is that acceptable? Not acceptable.
Acceptable.
Acceptable. Yeah?
Yes.
Yes, Sunita. That is acceptable. Now, one fine day, she said, "Ki, I need to go to hospital. Is that possible if I come 11 o'clock? Is that acceptable?
Yes, sir.
That is also acceptable. Someone please keep yourself on a mute. There's a disturbance. Sunita, are you on a... You're unmute, Sunita. Can you please mute yourself? Okay. Now listen carefully. If variation is in a range, please listen carefully. If variation in a range except variation out of range, reject. This 8:30 to 9:30, the variation is in a range. So this is acceptable. 7 to 11, it is out of range. So it is not acceptable. The variation once in a while, 7:30 and 11, is acceptable. The variation out of range by chance in a month, once she need to go to her son's school or in a hospital once in a month, that is acceptable. She is not coming in our time, but we can manage that. So variation which is in a range is acceptable. Variation which is out of range is not acceptable. It's reject. And out of range variation by chance is also acceptable. And this is the whole funda of statistics. Accept what is in a range, reject what is not in a range. Listen. This is a data made supposed to come at 9 o'clock. What is the range? 9:30, 8:30. In between, she can come anytime, and that is acceptable. The moment she start coming at 11 o'clock, that is out of range. Reject. This is out of range. Reject. If she come at 7 o'clock, reject. Because this is my limit. In our day-to-day life, we used to say, in a limit, I will tolerate you if you are in a limit, and I will not tolerate you if you go beyond my limit. I'll reject. So be in a limit. As long as you are in a limit, I'll accept you. In statistic also, as long as data is in a range, in an acceptable range, I will accept. The moment it goes beyond the range, I will reject. This is my central tendency. 9 is my central tendency. 9:30, 8:30 is my variation. This is my central tendency. This is my variation. The moment I get data, I find the central tendency, then I find the range. And if I found that average variation is in a range, I will accept. And that average variation is out of range, I will reject. If it's beyond my range, I will not accept. Because there is a good possibility that you may go wrong in that decision. Good possibility of going wrong. Because 7 to 11, if that is a variation, when the maid will come, I don't know. There is a good possibility if I take any decision, I may go wrong. And I don't want to go wrong in my decision. So I will rely on the data which is having a less variation. Because less variation means more consistency, more dependability, more reliable. I will be right if I take a decision if my data is a less variation. More variation, then you can see the less consistency, low dependency, and you can't rely on that data. Can you rely on a maid who will come anytime between 7 to 11? Not possible. So what you will do? Reject that maid. And go for a maid whose variation is less. Let's say 8:45 to 9:15 or 8:30 to 9:30. Here the variation is less. Means that maid's consistency is more. So you can depend on that maid. You can rely on that maid. You can depend on the decision you took for that maid. And this is what the whole statistic. We accept the hypothesis. We reject the hypothesis based on this funda only. If variation is within the range, accept. Variation out of the range, reject. That's a simple funda. Okay, any doubt till now? This is the most important concept. This is the base of your statistic. I told you the statistic is a decision science, and this is the base of that decision. How you accept and how you reject. This is the entire funda. Only two things you are doing. Find the center, find the variation. If variation is in a range, accept. If variation is out of range, reject. There is nothing more in a statistic apart from this. Yes, guys, any doubt you have? Till now. Yes, Pratibha, how we find the range, we'll talk everything about that. Those are the part of a numericals basically. Because how to find the center and how to find the variation, the moment your numerical change, that's why we saw the three types of central tendency. In a three ways we can find the central tendency: mean, median, mode. In a three-way we can find out the variation: mean, deviation, variation, and variance, and standard deviation. So depending on the type of data, depending on whether you need to take the decision on relationship, uh, differences, or prediction, so all the formulas will change, but basically the concept will be same. Yes, any doubt you have, guys? I just answered the question asked by the Pratibha. Are you clear till now? So far,
Yes,
so
sir.
good.
Okay.
Yeah. Now, this is what I used to say in statistic is a numerical based subject, and you have the uh, for one numerical, to solve the one numerical, you have the different formulas. Different formulas are there. Okay, so for standard deviation, what we saw just now, this formula, and this is a formula number 1, and this is a formula number 2. I use this formula to explain the concept, and I prefer this formula for numerical. No matter which formula you are using, your answer will be same. I found this formula most suitable to solve the statistical numericals as far as MAPC psychology IGNOU course is concerned. And I used to say to the student, put this formula on your mirror, and till your exam, just mug up this formula. This one formula can clear your statistic papers. Okay, so this is a formula. As far as exam is concerned, numerical practice is concerned, you need to practice from June 15 to June 23. Total 17 question papers you will get, plus 15 to 24. Total 9 assignments are there. So this total 26 documents. So as I used to say, all the numericals in the question paper, 17 question paper and 9 assignments, you need to solve. And this 26 documents, I will say theory plus numerical. You practice this much, that will be the more than sufficient for you to pass the subject. If you do the theory and if you do the numerical, theory from question papers and numerical from question papers and assignment. Don't open the IGNOU book. Don't open any other subject book for numericals. You do the numericals from this 17 question paper and 9 assignment. That will be more than sufficient. If you practice this much, easily you can clear your paper. Don't confuse yourself. Don't practice more numericals. Don't practice numericals from any other book, even IGNOU book also. Okay, just do this. Yes, Shweta. Shweta, I'm not able to. Where you will get the 17 question papers, Shweta, you can get the 17 question papers and assignment on IGNOU website. If you go on a Google and type IGNOU previous year question papers, so you will get all the question papers. Assignments also you will get, and I will forward it in the group. Okay, whatever the WhatsApp group we have, I already forwarded it, but again I will forward it to you. Yes, Ritu? You have the question? Ritu Bagla?
Yes, sir. Can you hear me?
Yes, please ask.
Yeah. So I was just looking at that formula, the second formula that you have shared, that x is
Yes.
xi, it's the same x both sides, right? One you are doing a square
Yeah.
and the other one you are doing summation, right?
Yeah.
Okay. But there's no x mean, is what I'm wanting to understand.
No, this is, I'm talking about the standard deviation formula. Mean,
Correct,
you
correct.
mean.
But like, in the earlier formula, you have x mean, na? X minus x mean. Yahan pe second formula mein, you don't need to refer to x mean, right?
Yes, but while, what I'm trying to tell you, while solving the numerical, you may need to find out the mean.
Achha.
That mean you may not use in a standard deviation का formula,
Correct,
but
correct, sir. Correct.
कहीं और use हो सकता है ना average.
सही है. Okay.
ठीक है?
Okay.
So
Yeah.
you need to go numerical by numerical.
Got it. Thank you.
Yes. Okay. Okay. So I believe. To check the assignment exam question answers, whether we got it right, how we do check that? Sahana Murli asked this question. So, Sahana, you can cross check with your friends. So, what group we already made, you can solve the questions, numericals, and you can share in the group. Others can check and confirm back. Number two, online calculators are available on the net. So ANOVA online calculator you can search, and on you can go on those websites, particular websites. You can enter your data and you can click on the solve the numerical. Then that website, that online calculator will solve your numerical and will give you the answer. So you can cross check by that way. Or there are books available in the market, and answers are given in the book. We do have the books also for that. You can cross check your numericals for that. Neetu's question: how you can be a part of that WhatsApp group? If you registered on the Google Doc shared by us, then at the end of the form you will get that Google form. Sorry, that WhatsApp group link. So you can click on that link and join the group. Or I'm sharing our WhatsApp number. You can WhatsApp on that number and you can request for a group link. Okay, we do have the batches, the WhatsApp group for every batch: January 23 batch, July 23 batch, July 22 batch. So we do have the WhatsApp group, so you can be a part of that group, or you can be a part of our statistic group as well. Okay, to discuss the statistic related questions. Descriptive statistic, we saw that in descriptive statistic, we need to organize the data and summarize the data. How we organize the data is table and a graph, and how we do the summarizing, that is a central tendency and a variation. The next is the inferential statistics. Okay, and in that we do have the population and a sample, and the most important point in your subject is a parametric and non-parametric. So I'll explain you the concept of a parametric statistics and non-parametric statistic. And once you understand this funda, statistic will become a cakewalk for you. So parametric statistic and non-parametric statistic. So parametric statistic is about the normal data, and this is the abnormal data. So if you have the normal data, like we have the raw data. You will get the raw data. In descriptive, in organizing the data, we saw that you will get a raw data. Now, if that raw data is a normal, if you find that data is a normal, then you go for a parametric statistic. And if that data is a abnormal, then you go for non-parametric statistic. It is as easy as that. If data is a normal, go for parametric. If data is abnormal, go for non-parametric statistics. Now, as I'm continuously telling you, statistic is a decision science. In other countries, they they have the MBA in decision science. So they are studying the statistic, because as a manager, you need to take a lot of decisions. So that is a decision science. Okay. Now tell me one thing. You like to take the decision on normal data or abnormal data? On which type of a data you like to take the decision?
Normal data.
Normal data. Yes. Anyone else? On which data you like to take the decision?
Sir, what is normal and abnormal data?
I will be
Even
discussing
I
that.
don't understand
Yes,
what is
yes.
abnormal data.
I will be explaining what is normal and what is abnormal. But by your common sense, I want the answer. You like to take the decision based on the normal data or abnormal data?
Normal.
Based on the abnormal, sir.
Abnormal data.
Normal data. We like to take the decision on normal data. And that's the reason why parametric statistic is widely used. Because parametric statistic is based on the normal data. 95% time we are using the parametric statistic. We are taking a decision based on the parametric statistic. But still we do have the non-parametric statistic as well. We'll discuss that also why. Now let's understand the concept of a normal data and abnormal data. Please listen me carefully, because this will clear the funda of what is a parametric statistic and what is a non-parametric statistic. Take any question paper, 10 marks theoretical question is always there on parametric and non-parametric. And students literally mug up this without understanding what is meaning of parametric and what is meaning of non-parametric. So please listen me carefully. I'll try to clear the concept of parametric statistic and non-parametric statistics. And for that, first we'll try to understand what is a normal data and what is the abnormal data. Listen me carefully. I want to find out the average age of graduate student in a university. Let's say, for example, Mumbai University. Now our Indian education system is 10 plus 2 plus 3 or 4. So 10 at the age of 16 student to clear the 10th, at the age of 18 student clear the 12th, and normally in first year you have the 18-year student, 18-year age, second year you have 19, third year 20, and fourth year 21. This is like an average normal student. Okay, so I randomly went to the university, I choose the age student, and I got the age 18, 19, 18, 20, 21, 20. Okay, so is this a normal? 18 to 21 age range I got in a university. Yes. This is the normal. Now, see, one student I found of 49 years age. Now, when I took the average of this, my average is coming, say, for example, 20.5. And I'm making a statement on an average, the graduate student in university, the average age is 20.5 years. So my statement is a logical statement. Now, one student is of a 49-year age I got, and when I took the average of this, that average is coming 25.5 years. Now I'm making a statement that on an average, the Mumbai University graduate student age is 25.5 years. Logically, my statement is wrong, because in statistics we called it as an outlier. The moment I have one data which is not a normal case, in a full-time graduate class, 49 age year student is not a normal scenario. So this is an abnormal case. Now the moment I take this data, and if I take any decision based on this data, then obviously I will go wrong. There is a good possibility that I will be wrong, because the abnormality in the data. So the moment we have the data, first we need to find out whether data is normal or data is abnormal. The moment you have the outliers in the data, that is abnormal data. Then you should not trust on that data. You should not use parametric test. You should use non-parametric test on such data because your data is abnormal. What is parametric test? What is non-parametric test? I will be discussing that also. This is the first scenario. If you have the outlier, then it is a normal data. Now see, there are few scenarios I will be discussing with you, how to identify the normal and abnormal data. If data is a normal and sample size is more than 30, always remember, any data less than 30 is abnormal. In order to do the statistical analysis, I must have at least 30 samples in my hand. That's a minimum. If I'm having a 30 samples, then I can say that data is a normal data. I can't go and take the decision for thousands of people just on the 10 sample. And when I say 30 sample, you understand one variable is equal to 30 samples. So if I am doing the gender study, it means male plus female, then I must have the 30 plus 30, 60 samples. Then that data is a normal data. If not, it's an abnormal data. If I'm using an age also, let's say 10, 11, 12 years, then I need to have the 30 plus 30 plus 30, 90 sample. Then it is a normal data and I need to use the parametric for it. Yes, any doubt? Please ask.
Sir, in the abnormal case, you said there is one outlier. Is it that can there be more than one outliers in the abnormal data?
I will be discussing that again. Okay.
Thank you.
Yes. Yes, Nidhi.
What will happen if data is normal but sample size is less than 30?
Then it is abnormal automatically.
Okay.
Sample size, the data is normal, but if the sample size is less, then you can't say that data is normal. Okay. First criteria it made, but it has to meet the second criteria also. So for any statistical analysis, you must have the minimum 30 people, 30 sample. Okay. Now, again, listen carefully. I went in the market and randomly I select 30 male. And I found that all the 30 male height is 5.10 inch. All 30 male height is 5.10 inch. Is that a normal data, abnormal data?
Abnormal.
All 30 people height is 5.10 inch. Normal or abnormal?
Abnormal, because we cannot take it as a population thing.
Yes.
Cannot represent.
Like
yes.
30 people won't have the same height.
Yes. So please listen me carefully. Variation is a natural phenomena. Please understand this. Variation is a natural. We all are same, but we all are different. Height, weight, body, IQ, shoe size, skin texture, hair texture, eyes, nose, ear, hand, fingers. Take any variable. We all are same, but we all are different. So, variation is a natural phenomena. No variation is an abnormality. If your maid comes exactly at 9 o'clock every day, this is the abnormal behavior. Understand, something is cooking in her mind. We can't be sharp at 9 o'clock every day. Not possible at all. Human being, variation is a natural thing. If she's coming exactly at 9 o'clock every day, something is cooking in her mind. She is planning something. Be careful. Variation is a natural phenomena. Variation must be there. What statistics says? Variation in a range is acceptable. Variation out of range is not acceptable. That's what a statistics. Variation will be there, but that variation must be in a range. Out of range variation, not acceptable. Okay. Now, if you are not able to decide whether my data is a normal data or my data is an abnormal data, so for that, in statistic, we have the test for normality. We do have the test in software. So we put the data in the software and we run the test of normality, and that test will tell us whether data is a normal data or data is an abnormal data. So if my data is a normal, I will use parametric test. If my data is abnormal, I will use non-parametric test. Now I will ask you one question. When I am not going to take any decision, okay, no decision I will take on non-parametric, then why to have the non-parametric statistics? 95% times I am using parametric. 5% times I am using non-parametric only. But why to use non-parametric when we are not going to take a decision on that? You don't trust abnormal data. You don't take any decision on abnormal data. Then why to break the head and learn non-parametric? In your exam, as compared to parametric, more numericals are there from non-parametric. Why to learn? Why to study non-parametric when you are not going to take any decision on non-parametric? Can you give me the answer? Yes, Nidhi.
To understand the possible variation.
For example?
Like, to know the good thing, bad का मालूम होना चाहिए ना kinds. तो अगर जो variation है, जो changes हैं, जो normal नहीं है, so by that we can predict normal things.
Okay, I think you are on the right track, but you're not using the right words actually. Saki,
Explain the abnormal.
Yes.
The abnormal psychology.
Abnormal psychology.
Explain the abnormal psychology.
No. Yes, Suparna?
Maybe to know the frequency of the abnormality?
No. Let me explain. We'll not waste time on that. Let me explain you. Because of the non-parametric statistic, we are alive here. We are alive because of non-parametric statistics. Listen carefully. COVID. Lockdown was there. Everything was stopped. And people were dying. COVID was everywhere. And we were in need of a vaccine. Now I told you for one variation, variable, we need a 30 sample minimum. Minimum 30 sample for one variable. Now imagine for the vaccine, sorry. In order to find out the vaccine for the entire world, you understand minimum sample size is 45,000. When you will test the vaccine successfully at a 45,000 people, then only you can consider that vaccine is a safe for the population. Now imagine 100 potential molecules for vaccine. Now, if I start testing this 100 molecules on 45,000 people, then I need to have that 45 sample size of 45 lakh. Imagine the time, effort, money, risk. In a COVID, when people were dying like anything, then I can't wait. The world can't wait to have the sample size of 45 lakh people. How much time? How much money? Then what happens? This 100 vaccine, they will test on, say, for example, 50 people. So 50 into 100, that's 5,000. Now imagine 45 lakh and 5,000 samples. When I will try the each vaccine on 50 people, it becomes my time will save, my effort will save, my money will save, my risk will be also less. And out of this 100 vaccine, potential I will get 2 to 3 candidates, molecules, which could be my potential vaccine. Now this 2 or 3, I can test on 45,000. That number is less, around 1 lakh or 1.5 lakh. So this 100 molecules I can't test on this because of these things. So I test on a 50 people, which is a sample size, a normal, less, because my all variations, my all variables are not getting into that. But with the less sample size, it will give me the direction 360-degree where I will look for the vaccine. So this non-parametric will give me the direction that your answer may be here, or your answer may be this. It is reducing my options. It is giving me the direction that you go in this direction. This may be your possible potential vaccine. It is eliminating the other candidates. The wrong candidates, it is removing automatically. That's the reason the non-parametric is most important, because it saves your time, efforts, money, and risk. It gives you the potential answer, not the exact answer, but the potential answer, the direction in which your answer could be there. And you can reach to that answer in a speedy way. Else, if you keep depending on a parametric, it will take a hell lot of time, efforts, money to reach to the answer. That's the reason why, though we don't take a decision on non-parametric statistic, but non-parametric statistic help us to take the decision in a faster way by eliminating the wrong option and by giving you the potential answers, potential solutions. That's the reason why we also use the non-parametric statistics, and it is equally important as compared to parametric statistics. Am I clear? Any doubt you have till now? Yeah, any doubt? Okay, so let's go to the next point. Again, let's understand the concept of why. What need to be done with the normal data and abnormal data. See, this is my normal data and this is my abnormal data. Now remember one thing, as I told you, this is my data, this is my center, this is my limit. What I will do if my variation is here? I'll accept or reject.
Reject.
You will reject because it is out of limit. Now listen carefully. If my center shift here, what happens? My center shifted. The moment my center shifted, my limit will also shift. And now the point which you supposed to reject, you need to accept. Example, 9 o'clock maid should come. 9:30 to 8:30 is the limit. Now if my time, my center shift, okay, imagine she used to come at 9:45, so technically I should reject. But if my timing 9, it changes to 10, then the 9:45 which I supposed to reject, now I need to accept that because it is in a range. The same thing is happening here. The point which I supposed to reject, I am accepting it. Now the point which I supposed to reject, I am accepting it. It means that I started taking wrong decisions. The things which I supposed to reject, I am accepting it. Means I am taking a wrong decisions. And that is a risky. And why this happens? Because my mean shifted. Listen carefully now. This is my normal data. My mean and my median is 40. The moment I have outlier here, my mean shifted. Now my mean is 60. But if you see carefully, my median is intact. What is median? 1, 2, 3 point this side, 1, 2, 3 number this side. 1, 2, 3 number this side, 1, 2, 3 number this side. Now when we talk about the abnormal data, that data could be abnormal in any possible way. This is my normal data. This is my abnormal data. Abnormal data. Abnormal data. Abnormal data. Now here my mean is a 4. Do you think that my mean in case A, B, C and D, my mean will be same?
Yes.
My mean will be same.
Because like there are 7.
No, 7 numbers are there. This could be, understand, this could be 10, 20, 30, 40, 50, 60, 70. Now this could be 80, 100. This could be 300.
No, mean cannot be same.
My mean will shift. Now if my mean is keep shifting, do you think I will be able to take the right decision?
No.
No. But in order to keep the mean intact, I will use in order to keep the central tendency intact, I will trust on median. Because in all the scenario, 1, 2, 3 this side, 1, 2, 3 this side, my median is intact.
Yes,
in
median
case of abnormal data. So when we have the abnormal data, the central tendency which I will use is a median, not the mean. Because in case of abnormal data, my median is more consistent. No matter what numbers are coming, my median is always in a center. And hence median is a more reliable, trusted, dependable central tendency when data is abnormal. So for non-parametric test, I depend on a median as a central tendency. For parametric test, I depend on mean as a central tendency. Reason? Because I don't want to go wrong in my decision. And the moment central tendency shift, I start making wrong decisions. And in order to keep the central tendency in a center for abnormal data, I will use median as a central tendency. That's the reason why we do have the number of central tendency. That's the reason why we do have the number of variations. Okay. So based on the data what you have, based on the thing what you need to do, whether you need to find out the relationship or you need to find out the difference or you need to find out the predictions, you need to use the right tool, right central tendency, right variation at the right place. It's just like a cooking. If someone asks me to go and make a tea, I should not take the cooker. I should not take the frying pan. Because that is not a right tool to make the tea. And the moment you take the wrong tool, I'll understand you don't know how to make a tea or you don't know how to cook. That's the reason why in a statistic, the moment you choose the wrong tool, I understand you don't know the statistics. So before doing the statistic, it is important for you to understand the statistic. You need to understand what is a parametric. You need to understand what is a non-parametric. What is parametric? If I have a normal data, I will use parametric. If I have abnormal data, I will use a non-parametric. If I am having a normal data, I will use mean as my central tendency because that is a more stable. If I am having abnormal data, I will use median as a central tendency. That is because that is a more stable. And I will go for a non-parametric. Now you can understand that for every parametric test, there is a mirror or counter non-parametric test. Because I don't know what kind of a data I am getting. That data could be normal, that data could be abnormal. So if I am having a normal data, I will use t-test, that is a parametric. If data is abnormal, I will use the u-test. If data is abnormal, I will use the u-test. So t-test and a u-test basically perform the same thing, that is to find out the difference between x and y. But I will use the t-test if data is a normal. I will use u-test if data is abnormal. I will use ANOVA. ANOVA is a parametric, so my data is a normal. I will use ANOVA. And Kruskal values ANOVA I will use if data is abnormal. I will use Pearson correlation if my data is normal to find out the correlation. If data is abnormal, I will use Spearman or Kendall. So for every parametric test, I am having the counter, opposite or mirror non-parametric test. So if my data is normal, I will use parametric, t-test, ANOVA, Pearson correlation. If my data is abnormal, I will use non-parametric, u-test, Kruskal value, Spearman, Kendall. That is a simple funda for parametric and non-parametric. Yes, guys, am I clear?
Yes, sir.
Okay, please ask if you have any questions. I'll be more happy to answer your questions. Please. I done from my side for the day. I explain you what is a descriptive, what is a descriptive statistic I covered basically. and I cover also the parametric test and non-parametric test. I explain the concept of normal data, abnormal data. Now, with the help of this, now today, if you go and read the what is parametric test and what is a non-parametric test, I'm sure you will understand it in a better way, because now you know the funda. Yes, Madhu, Banti, you have any question? Yeah, please ask.